All right, off we go. Day 67. In the book, we're in 7.2, which is surface area, and the goal of the 3-minute review. And I've got a whole bunch of stuff written down, and hopefully you'll just listen to me as you're madly copying down all the right words and stuff like that. But surface area, one of the things that's useful for us is to think of a three-dimensional shape taken apart and lied flat, because then we can just use our formulas from last class, to find out the area that would make them up. If this was made up of cardboard, what are the little bits and pieces that make up the surface area of that shape? One thing that we might get confused on sometimes is this idea, what's the difference between a prism and a pyramid? A prism has two parallel faces, and then there's rectangles that join them, right? Whereas a pyramid, it comes to a point, a single point, like a pyramid, right? And so this one, you say, well, hang on, there's a triangle. No, those are the two parallel faces. Those two are exactly the same, and then the other faces are rectangles. That's how I know it's a triangular-based prism. This one, I can see the triangles would fold up to a single point, and it's a square-based pyramid. And you see the other ones. This one is what a cylinder looks like if it was cut apart and lied flat. A cylinder would look like two circles and then a strip in between them. Another interesting one is, this one here. This is the base, and we're missing the other base. The other base must have got thrown out or something. But the base is a hexagon, a six-sided figure. And if I folded all these rectangles back up, this part here, these are called the lateral faces. And if I folded them all up, it would be missing its other top. And of course, because they're all rectangles, then it's a prism. Had these been all triangles, then I could probably have guessed that it's not a beautiful flower, although it kind of looks like a beautiful flower. That if they all came up to a point, that would be a hexagonal-based pyramid. This one, which kind of looks like a bell shape, this is actually a cone, right? A circle on the bottom, and then if I curve this around, this would make a cone. And this kind of looks like a piece of a circle, and we'll talk about pieces of circle later in this chapter as well. All right, so good. Hopefully you got all those. And on to the questions. Now you're going to need to squish here. I realize I never gave you much room, and there's going to be quite some calculations here. To find the surface area of shapes like this, what we do is we add up the faces. And these faces are made up of shapes that we're usually pretty good at calculating the area for. And again, you're going to need to squish. You're going to need to use all the room here. Find the surface area. Well, how would I describe this surface area? And I'm going to write it down here. For some reason, the cylinder's got lots of room, and this one is actually going to need more room. How would I describe the surface area? Well, I see it's a front and back triangle. So it's two triangles. Two area of triangles. Plus, because of these ticks, do you see how the bottom rectangle and the side rectangle, and actually it's a square, right? Because this is 5 centimeters as well. There's two squares, right? The bottom and the left side of this shape are both squares, and they're the same. And notice I'm trying to look for a shortcut. This thing actually it's a triangular-based prism. It's actually got 5 sides, but I don't want to do 5 different calculations. I want to look for shortcuts. And notice I've already got some shortcuts. This slant side here is a rectangle, and it's the only one that's its shape. And now what I'm going to do is I'm going to do calculations around this thing to see if I can figure out what these are. So for the triangle, that's just base times height divided by 2. Base times height. The base is 5. And the height's 5, and so I can jam that in there. That's 12.5. So down in my formula, that's going to be 12.5 centimeters squared for the two triangles, and the two squares. That's just 5 by 5. That's pretty easy. I'd probably just do that right in my. The length is 5, and the width is 5. 5 times 5 is 25. So the bottom and the side are both 25. And this slant rectangle is actually going to be a bit of a pain, because even though we know this side is 5, that side's unknown, right? This side along here, don't know it. But we can find it, right? Pythagorean Theorem. And this is good, clean fun, these measurement problems, aren't they? It's like all of the concepts of the whole year are all built up in here. 50, and then square root of 50 is about 7.1. So if I wanted to find the area of this rectangle, length times width, 5 or 7.1 times 5 is 35.5, and I'm getting all squished here, but you should be making out okay. And then the surface area is just all these little bits and pieces added up. Okay, and I did that, and I think I got 110.5, and the units, because it's still an area, centimeters squared. Now, cylinder. Cylinder, I'd love to break it into its faces, and I saw that it's actually 2 circles and then this rectangle. Now, the rectangle is kind of weird, right? The 2 circles, no problem. Area is 2 circles, plus, I said it's also this rectangle. This rectangle, well, how does that work out? Well, I see that rectangle, right? So this is the worst net ever, but and this is sort of turned on its side. Maybe I'll do it this way. Right? That circle's there, that circle's there. The height of this rectangle is just the height of the cylinder. This is this 8 inches. That's the height. But when I unroll it, what's this? Well, this has kind of got a curve all the way around this circle. This here is actually the circumference, isn't it? The circumference is this. So this area of the rectangle is, I got 2 circles, and that's pi r squared. And the rectangle is the circumference, 2 pi r, and then times the height, right? It's just a rectangle. And in fact, that's the formula for the surface area of a cylinder that's on the formula sheet that you've got. And notice they've got this, the lateral surface is sort of the curved part that we're talking about, and if you choose to use the formula, you can go right ahead and do that. This one's actually easier than the last one, isn't it? The radius was 8 inches divided by 2, 4 inches, and the height was 8 inches, the distance between the 2 parallel faces, of course. Radius was 4 squared. And I think probably after you get this all written out, you can carefully now put that all into your calculator in one step. 2 times your pi button times 4 squared plus, and then put it in exactly as it appears, and you should be able to get pretty close to the answer, 301.59 square inches. All right, easy peasy, right? On to one of these practical problems. Yeah, that's practical. How much corrugated aluminum will it take to construct this silo? Okay, so this is a silo, and it's one of those filled with sand or grain or whatever they put in silos. What I'd like to see is how they're going to bend corrugated aluminum into this top part, which looks like a sphere, right? So here, the surface area is the area of a hemisphere, right? A half sphere. Plus the area of the cylinder. Now, we've got to be careful and smart here. In this silo, Notice, of course, we're going to need to find this lateral area, but are we going to put aluminum on the floor? No. Are we going to put aluminum on the roof? No, because then we can't fill the whole silo with grain. And I don't know if they fill silos from probably from the top, I guess. But we're not going to have a roof or a floor on this thing, right? So we got to be careful. No roof and floor. So that means no circles, right? That's going to make our life a little easier, I think. So the area of the hemisphere, well, do you remember what the surface area of a sphere is? Probably not. Well, let's look on our formula. Surface area of a sphere is 4 pi r squared, which is pretty cool formula, by the way. 4 pi r squared. So somehow, in a whole sphere, there are 4 circles, which is pretty neat. Now, because it's a hemisphere, we have to divide by 2. So this is actually 2 pi r squared is going to be our formula because we only need half. And the radius was 10 feet. So I got 2 times pi times 10 squared. Again, we're using our pi button. We're not using 3.14 because we want to be exact. Times pi times 10 squared equals about 628. 628, and that's square feet, right? So that's this one, 628 goes there. Plus the lateral area, right? We don't need, if I go back to my formula, I don't need the 2 circles. I just need the curved part. I just need this lateral surface area here, the 2 pi r squared, or 2 pi r h rather. All right, no worries. 2 pi r h. R is 10, the height is 16, 2 times pi times 10 times 16, bada boom, bada bing, on the calculator, and what did I get? Of course, I didn't do that in my calculator. Darn. Here we go. 2 times pi times 10 times 16, about 1,005. Add those together, and it looks like about 1,633 square feet. And that, once we end it, it would take once we get the sentence written to answer the question we were asked, I think is it for surface area. Yeah, that's it. Good luck on the homework, and make sure today that you make wise choices.